Alrighty guys, we are going to add to our notebooks today. Today we're going to talk about some properties of logarithms, and this will help us rewrite logarithms in different ways that can be helpful when we want to start solving when there's a logarithm involved. So I really like this section because to me it just feels like we're playing with numbers. We get to like move them around and do fun stuff with them, but it can be a little bit weird for some people. So logarithmic, oh my gosh, spelling, properties. We're doing that on 93 and 94. I'm probably going to make this into 2 videos where we talk about some straightforward logarithmic properties in the first one, and then in the second one, more logarithmic properties that will help us when we actually do get to solving in the 3rd video from now. All right, here we go. So we got 93 and 94, and we're going to start on this one here. So I really think you should do that math lab that is attached with this. I think it'll help you to understand these properties a little bit better. So after doing that and coming here, we should have found out that our product property says if I have log base b of m plus log base b of n, then I could rewrite that as log base b of m times n. Now I put an arrow in between because it can go either way. Like if I have 2 logarithms being added, I can smush them together to make 1 logarithm with those 2 numbers multiplied. Or if I have 2 numbers multiplied, I can split them up into 2 logarithms that are being added. Our quotient property, hopefully it also kind of makes sense. Like I feel this one makes sense and feels good. If I have a log base b of m minus a log base b of n, then I could rewrite that as log base b of m divided by n. And again, I just feel like addition and multiplication kind of go together. Everything's getting bigger here. And subtraction and division just kind of go together. Everything's getting smaller there. The last one is kind of the weird one. The power property basically says if I have a, let's just make it a letter, a number in front of a logarithm, then I can rewrite that in the power. So it's kind of like this front number here gets booped back, or you can think about the back number getting booped forward, either way. Okay, so really what we want to talk about with this is when I have lots of logarithms, how can I smush them down into 1 using these properties? And then if I have 1 logarithm, how could I expand it out into as many logarithms as possible? Again, using these properties. So like on the inside here, I kind of have to mix and match all the properties. It's hard to do just like one property on its own. But what I do want to do is on one side, we're going to talk about how we condense using logarithmic properties. Come on. And then on the other one, we'll talk about how we expand logarithmic properties. Okay. So let's say that we have something simple to start. Let's start with our condensing. If I had something simple like log base 3 minus, I'm sorry, log base 10 of 3 minus log base 10 of 9, then, okay, so I'm starting with lots of logarithms. We want to smush it down to 1. This is a pretty basic one because it only uses 1 property. We just have 2 numbers being subtracted. So I'm going to change it to division, which then I could simplify to be log base 10 of half. So we might do it that way. Okay. But usually for us, what's going to happen is we might not actually be able to simplify very much because there's going to be lots of letters involved. So let's say we have natural log of 4 plus 3 natural log x minus natural log 2 minus natural log y. Okay, so we're starting with lots of logarithms and we want to smush it all down to 1. And so if I rewrite this with just one natural logarithm, I can kind of see what's happening here. I have a 4, then a plus. So I know I'm going to do 4 times something. And then this 3 is going to boot back. So 4 times x to the 3rd. And then both the next two numbers are being subtracted. So both those next two numbers are going to be divided. So 2y. And then I can simplify a little bit because the 4 and the 2, we can rewrite that as 2x to the 3rd over 1y. So kind of a bigger example there. Or maybe something like this. If we had half log base 2 of 3x plus log base 2 of 2y. Okay. Now, because of the parentheses, this half kind of goes to both logarithms. And because it's a front number, it's going to go back into the power. So we're going to have our log base 2. First number I see is 3x, but it is going to be to the half power. And then plus, so times 2y, which is also going to be to the half power. Which, if you remember, a half power is kind of like a square root. It's totally a square root. And both of these have a half power, so I'm just going to write a square root. They're all under it, so 3 times 2 is 6, and then xy. So that's kind of fun. Let's try a couple more here. Let's say we have 2 log base 3 4x plus log base 3 2y minus log base 3 4xy. Okay, so lots of logarithms. We're going to smush them all down to 1. So it will be log base 3. The first number that I have, 4x, has an exponent right here. This 2 is going to come back, and it goes to both. So like 4x squared. Plus sign next, so we're going to multiply, but this one does not have a power, so we're just timesing by 2y. And then we have a subtract, so everything here is going to be divided by 4xy. Which then I can see that some stuff will actually simplify. So log base 3. I have 2 4's here and 2 x's here, which can cancel with the 4x right here. So we'll just have a 4 and an x left. And the y can divide with the y, so I think we're just 8x. OMG, after all that, yeah, just 8x. Fun. Okay, I have to grab something really fast. Then I have one more good one to try. Okay, so another way that we can kind of use this in a clever way, these are kind of the harder examples I feel, but when we actually know the numbers, so if we're log base 2 of 16 times 32, here's why this property like comes in handy. You know, I could multiply those up and get a really big number, but that feels like a bad time. So instead, I'm doing this the wrong way. I'm doing the wrong side. Just kidding. Let's try that again. Log base 1/5 of 625 minus log base 1/5 of 25. Okay, again, as I was saying, I could do log base 1/5 of 625, but 625 is kind of large. Maybe I don't want to do that. Over here, it's not so bad, but because I have this property that says if I'm subtracting, I can instead divide. So I can rewrite this as log base 1/5 of 625 divided by 25. That will make things a little bit easier because 625 divided by 25 is 25. And then log base 1/5 of 25 is much easier to figure out. So I'm not dealing with such a big number. This will just be -2. That's maybe why our properties can come in handy. Okay, let's talk about expanding. I got ahead of myself a little bit there. So let's do an expanding example. So that one that I had originally written down. So log base 2 of 16 times 32. So I can tell that we're going to expand here because I only start with one logarithm, which means we're probably going to want to expand out. Now, I wouldn't necessarily have to here. I could just do 16 times 32, but that feels like a really bad time because it's going to be a really big number. So to make it easier on myself, I can split it up to log base 2 of 16 plus log base 2 of 32. And then finding each one of those is a little bit easier, like log base 2 of 16 is 4, log base 2 of 32 is 5, and so overall it's just 9. So again, this is why using these properties can be a little bit helpful. Okay, so trying some more expanding ones where there's like a little less math involved, more just playing with numbers. Let's say we have log of x divided by y to the 6th power. So when I'm going to expand, I can always tell how many logarithms I need by counting how many numbers I have. So here I have 2 numbers, so we need 2 logarithms. First number is x, second number is y, which does have a power, so 6 comes out front. This one did not have a power, and because they are being divided, we put a minus. So I'm kind of like doing the problem in a weird way where I write it all out and just kind of fill in the blanks, which can be hard for some people, like they want to go step by step. Let's try another one here. Let's say we have log base 2 of ab squared. Okay, so again, because I have 2 numbers, I can tell I need 2 logarithms. Base 2, there we go. And those 2 numbers are being multiplied, so we're going to have a and a b added. And they are now both to the 2nd power, so they need 2's in front of both. So I guess the power is kind of what I'm thinking about last. Let's say we have this. Natural log of 2x over y to the 3rd. Okay, so a little bit like that last one. This time we're going to have 3 natural logarithms because there's 3 numbers. So natural log, natural log, natural log. First number is 2, then an x, and then a y. The 2 and the x are being multiplied, so plus. The y is being divided, so minus. And they are all to the 3rd power, so 3's in front of everyone. Now you could technically also put the 3 in front of parentheses, kind of like this one had here. Whichever way you think is more simple. It's kind of all the same to me. And then maybe 2 more to try. Let's say we had log base 3 of cube root xyz, like this. Okay, so again, I can kind of tell that I'm going to need 3 logarithms because we have 3 numbers. So log base 3, log base 3, log base 3. Oh my goodness, I'm going to cough. Excuse me. My numbers in order go x y, z. I know there's cube root. We're getting there. The x and y were being added, multiplied, so added. The z is being divided, so subtraction. And they are all under a cube root. So all under a cube root means that they all have a 1/3 power. So I could put a 1/3 in front of each one, but this time I'll do the parenthesis thing like that, just because I kind of ran out of space. But either way is good. Okay, let's try one more, and then we'll be good to go here. So let's say we have log base 5 of a root b over c squared d. Okay, so this time I can tell that I need 1, 2, 3, 4 logarithms. I'm going to write this on the next line. So log base 5, log base 5, log base 5, OMG log base 5. Squeeze that guy in there. My numbers in order are A, B, C, then D. Now A does not have a power. It's being multiplied by B, so plus. B does have a power, it's half. So that goes out front. Next, C is being divided, so minus, and it has an exponent, so 2 out front. And now here's the tricky thing. D is being multiplied with C, but D is being divided overall. So it really does need a minus, or you need parentheses around, like whichever way it makes more sense to think about it for you. Like you could either write this as I have, so 2 minuses, or if you put like minus 2 log base 5 of C plus log base 5 of D, like this. So you're like, okay, these are multiplying, but they are both divided with parentheses around. Either way. And D did not have an exponent, so no number out front. Okay, I will have more properties for you in the next one.